We know that the biggest recent change in our history is Industrial Revolution that changed the modes of production. And after this Industrial Revolution, there came a lot of changes in actually 4 and all the dimensions of existence, that material, biological, social, and cultural dimensions, I mean. Some of the changes include demographic changes from high fertility and mortality to low fertility and mortality. Other changes like epidemiological transition, urban transition, energy, economic, nutrition, important one, biological, cultural, and democratic transitions. These transitions also affected our food and nutrition system, and now we are producing more food and solving the old problem of food shortage. And that was part of problem in traditional systems. But this comes with some costs, including environmental and nutrition costs. Of environmental costs, we can say rapid soil depletion, high water consumption, changes in climate are some of the issues in terms of environmental costs. In terms of nutrition, we still have triple burden of nutrition, obesity and overweight, at the same time hunger and micronutrient deficiencies. So sustainable diet is an approach or is a solution for these problems, and according to FAO's definition, sustainable diets are those diets with low environmental impact which contribute to food and nutrition security and to healthy lives for present and future generations. In this paper, we use sustainable diet approach to draw dietary recommendations that have less water-intensive food items. The context of the study is Iran. It has 28% of mild food insecurity. 1/3 of population consume more food than it's needed. Also, Iran suffers from shortage of water resources. The average rainfall in Iran is less than 1/3 of the global average. And you can see here in this picture that Lake Urmia in northwest of Iran is dying out, and it took less than 20 years to change from this one to this. And water is the main issue now. The data comes from Urmia city, capital city of North Azerbaijan in northwest of Iran. We had a sample of 723 and used FFQ or food frequency questionnaire with 168 items. Water footprint approach we used, and the data for water use that's published in cubic meter per ton are reported for Iran and sometimes for West Azerbaijan for all food items that we had. In terms of components of the water footprint, there are 3 components: blue water that comes from surface and groundwater, green water that means rainwater, and gray, the amount of fresh water that's used to assimilate the load of pollutants. We use linear technique, linear programming approach, and we have 3 scenarios. The objective in all 3 scenarios is to minimize blue water, and changing variable are all 168 food items. The constraints depends on the scenario. For the first scenario, in order to take into account the cultural preferences, we want all items to vary between first quartile and a maximum of third quartile. And also we let the energy to be equal to real dietary energy. For the second scenario, the same constraints plus food items that was recommended or food recommended serving size by Iranian food pyramid. For third scenario that we think that's healthier than the other 2, we also, other than these constraints, we add intake of micronutrients and macronutrients and energy intake equal to dietary reference intake. About the results, as you can see here, the real diet has more consumption in almost all groups except milk, yogurt, and cheese, which has 2,920 kilocalorie of energy. It weighs 2.2 kilograms, and it uses 4.1 cubic meter of water per person per day. The third scenario that follows all the guidelines of this recommended serving size, it has 2,675 kilocalories. The weight is 1.4 kilogram. The amount of water that's needed is per person per day is 2.1. That's almost half. In terms of the components of the water that's used for real diet, 2.4 cubic meter of green water, 1.18 of blue water, and 0.5 of gray water is used. But for third scenario, it can go down from 2.4 to 1.4, and for blue water, it can go to 0.41, and for gray, it can be 0.29. And in terms of percent reduction in water use compared with real model or real diet, we can see that in the third scenario, the amount of green water reduction is 42%, blue water reduction is 65%, and 43% of gray water reduction. In total, 48.9 or 49% reduction in water can be expected. The contribution of different food groups in energy intake compared with between third scenario and the real diet, for bread group that was contributing 39% of energy, it declines to 25%. Vegetables decline from 8 to 4%. Fruits increase from 8% to 14% of calorie. Milk increases from 15% to 29%, and meat, poultry, and fish decreases from 14% to 11%, and fat and oil almost unchanged from 16 to 17. As a next step for our research, we are going to present or calculate these models based on socioeconomic variables, and this is one of the initial results for household wealth score. As you can see, high socioeconomic families or households are using more water compared to low socioeconomic status or low wealth score families, and the amount of decline between real and third scenario you can see here. In conclusion, we can say that a healthy diet which takes into account RDA nutritional recommendations and Iran's food pyramid guidelines needs 2.1 cubic meter of water per day, and it's 49% less than the amount that's needed right now for real diet or existing diet, and the share of dairy and fruit increases in this diet, but share of other food groups almost decrease. And finally, a healthy diet with greater proportion of fruits and dairy instead of a diet with high consumption of meat group and bread group can supply all recommended dietary allowances while reducing water use. Thank you.